Welcome to our lesson on graphical method, lesson 4, which we are going to deal with the equation of a circle, general equation that represents a circle. We also know general equation that represent a straight line. Y is equal to mx plus c. That is a general format of equation of a straight line. Now we are going to look at a general equation that represents a circle. Okay? So you can have your graph paper. You can have your graph paper and then you just draw a circle. Okay? From there, on your Cartesian plane, you can easily get a backup of what I'm going to talk about. But this is the basic, okay? You have a center, then you just open your compass, you draw a circle, okay? Now, let us look at what I've done. I've just drawn, I don't have Cartesian, the grid, the one which shows the number, but I will use the board and you will still get the point. So you draw a circle. A circle must have a center. It is from the center that we are able to draw a circle. So let us imagine we've drawn a circle at the center of Cartesian plane. So what is the coordinate of that center? R 0, 0. That is the coordinate 0, 0. Okay? So you draw a circle of any radius. Okay? Now, if you pick a point P there and give it its general coordinate x, y, general coordinate x, y, what does it mean? From the center up to this level is x units, and then you go up y unit. So we are assuming that this P here, you can read its x and y coordinate perfectly, right? So what is the meaning of xy? From the center you have moved right x units, and then you have gone up y unit. So we want to see the relationship. Now when you have that and you drop a line to x-axis or horizontal line, generally it should be horizontal line or abscissa or abscissa. All horizontal lines are also known as abscissa. All vertical lines are also known as ordinates. But for beginning, I'll say drop it to the x-axis. At the back of your mind, drop it to abscissa. You drop it and you get a right angled triangle RQP. Since it's a circle, radius R, we can use the triangle to come up with a relationship. Okay? Any distance from the center to circumference is a radius. Therefore, I have put here hypotenuse of my triangle R. This length, you get it by saying x minus 0. X minus 0. Because here it would be x. And then this level is y. Here it would be y. And this level would be, let us put the letter Q here, and this would be x. So to get this length is x minus 0, which is x. To get this height, it is y minus 0, which is y. Using the triangle PQR, hypotenuse squared is equal to adjacent squared plus the other side squared. So instead of P RP. Instead of RP, I put letter R. Rightly so, because it is the radius of that circle. RQ. From RQ, it is this number minus this number. In my case, x minus 0. The x's are subtracted, the y's are subtracted. Then you get that is the relationship. So this is a general formula that tells us there is a circle whose center is origin and it has radius r. Okay, let us look at the second one. Maybe you will get it better. Before I come to the second one, I want you to focus down for explanation. Suppose I have this center now. My center is 1, 3. So I'm talking of R. R is 1, 3. R stands for the center. Capital R is the center. Okay? Capital R is the center. This. So I have now R. This is Q. So our P is somewhere here. So from P, I drop a vertical to meet an abscissa through the center. You should be getting that language right. From P, drop a perpendicular to meet a horizontal line through the radius. This is the abscissa I'm talking about. This is the horizontal I'm talking about. What is its qualification? Is a horizontal line passing through the center. Abscissa through the center. Abscissa through the center. A horizontal line through the center. They meet with a line dropped from P at point Q. So at point Q, it is 90 degrees. If I join R to P, I get a right angled triangle R, P, Q. Pythagoras theorem deals with lengths. Length R, P, capital R, P is radius. Length from R to Q, you subtract the ordinates. The value of this ordinate is x is equal to 4. Here is x is equal to 3. Like what we do, longitude difference. So here we say ordinate difference. Okay? And then this PQ, it will be abscissa difference. Horizontal line difference. Okay? So what do we do now? This is level 3 and this abscissa is level 1. So 3 minus 1 gives you 2. So ideally, if I wanted to know the radius of this circle, I would say 1 squared plus 2 squared. So 1 plus 4, if you get the square root, that would be the radius of this circle you have drawn. Right? You do it practically. This is not something that you will need. It is not abstract. It is something you do. You get point P somewhere, and since you are dealing with the graph paper which has already drawn grid, look for a good point whose line already exists so that you are able to count the boxes. Boxes are 1 unit. So if I get the number of boxes here, you square. The number of boxes here, you square. The square root of that should be the length of the radius you have used. Back to our question, just focus again. So let our radius, our center be at 0.31. Remember the first one was 0, 0. Now 31 gives you an idea of the abscissa difference and ordinate difference. Ordinate are vertical lines. Abscissa are horizontal lines. Mathematical language. You don't keep on saying horizontal, horizontal, horizontal. No, use the right language. Right, so we come here. This, it tells us this is an x coordinate, this is an y coordinate. So there is a vertical line through 3. There is another vertical line through x. So to get this difference here, to get ordinate difference, the difference in vertical lines, one at 3 and another one at x, we just say x minus 3. You can see here, r q, x minus 3. Come to qp, qp. So there was, this is level y. If you went to the y-axis somewhere, this is y. And this here is 1. Because you can see, this is x and y. So it is the difference in those lines. Okay? So this is x, subtracts 3. This is y, subtracts 1. You draw it, you get the real stuff I'm talking about, okay? You would easily get now, in this case, what is the level of P? You can go up to the y-axis, then what is the level of Q? This Q, because we are looking for this difference, sorry. We are looking for this difference. So this, its level, and Q, its level. That's what I'm talking about, okay? So that is abscissa difference, because there I am operating with horizontal lines. But if it is the difference on vertical lines, we say ordinate difference. That is the language you encounter when you are doing area approximation by trapezium rule and mid-ordinate. Mid-ordinate, middle of the vertical lines. Ordinate, they are vertical lines. So middle of those vertical lines given. That's why we say mid-ordinate. Okay? So if I get y, and this, it is level 1 from this point, so it is y minus y. Here it is x minus x. Those are the ones which give you the lengths of that right-angled triangle. So we have QP is y minus 1. Using Pythagoras, RP squared is equal to RQ squared plus QP squared here. Now I put the real stuff. Okay? RP is R squared is equal to, what is RQ? Its magnitude is x minus 3. Magnitude, length, size. QP, y minus 1. So this becomes a general equation of a circle whose center, look. So if I'm asked here, if I'm given this, maybe we conclude now. Suppose I rub here. If I'm given 25 is equal to x minus 4 squared plus y plus 8 squared. If I'm given this, you can see when the center is 3, x coordinate is 3, it appears as opposite, minus 3. When it is positive 1, appears as opposite. So what do? These terms are already in square form. this is not in square form. So I write 5 squared is equal to x minus 4. So we focus down a bit. This is not in square form. So 5 squared is equal to x minus 4 squared plus y plus 8 squared. Therefore, my radius, you can see, this is the radius. This is the radius. My radius becomes 5. The center, R, is equal to 4 minus 8. So, from equation to the center, they are opposite signs. Okay? Using this example, you can clearly see 3 as the center. In the equation, it appears as -3. So that's why here, the equation is +8. So in the diagram, it will appear as -8. That comes from derivation. So you come up with that conclusion. So we are going to do another lesson that will be a bit tricky, but we'll try to implement the pieces that we have learned. Till then, keep on subscribing. You get much stuff. There is comment in the YouTube. There is provision for comment. So you can also say there, this topic of Form 1, Form 4, can you iron out something? Bye-bye.